morning, friends. Good morning, ma'am. It is Felix Valentino Sianturi here. I want to explain you my mini research result PowerPoint about characteristic of sulfur and its compounds. Sulfur is a non-metallic chemical element belonging to the oxygen or calcium group or group 6A of the periodic table and is one of the most reactive of the elements in that group. Before I continue explaining, here I want to deliver you firstly the contents that I will explain in this video. The first, physical properties of sulfur. The second, periodic properties of sulfur. The third, reaction between iron 2 sulfide and hydrochloric acid. The fourth, reaction between sulfuric acid and copper metal. And the last one is the references that I use completing my slide. The first content, physical properties of sulfur. In this part, I divide into two parts of the properties of sulfur, namely properties that can be directly observed and that must be measured first. Properties that can be directly observed. The physical state of sulfur in 1 atm pressure and 25 degrees Celsius temperature or in a room temperature and pressure condition is solid. The solid is yellow, odorless, and tasteless. Properties that must be measured first are melting point is 122 degrees Celsius, boiling point 444 degrees Celsius, atomic number is 16, atomic mass is 32.06 gram per mole, electron negativity is 2.5, density is 2.07 gram per centimeter cubic, atomic radius is 1.03 Armstrong, ionic radius is 1.7 Armstrong. First ionization energy is 1000 kJ per mole. Second ionization energy is 22 and 52 kJ per mole. Third ionization energy is 33 and 57 kJ per mole. And the standard potential is minus 0.51 volt. In natural, sulfur is much found in the form of cyclooctasulfur, or as we know as S8 in the molecular formula. The cyclooctasulfur is one of the sulfur allotrope. From this table, we can see the physical properties of group 6A in RTP condition. The properties of oxygen are not very similar to those of the other group 6A elements because the properties of elements in the second period usually differ significantly from those of other elements in the group, and the second period elements have no low energy d orbitals. So, each of the group 6A elements except oxygen can bond covalently to as many as 6 other atoms. This table I took from the book Chemistry 9th edition written by Whiston and Friends. The video completing my slide you can see in the end of my explanation. Let's go on to the next content explanation, periodic properties of sulfur. The first, electron affinity. The electron affinity or EA of an element is the negative of the energy chain that occurs when an electron is accepted by an atom in the gaseous state to form an anion. The more positive the electron affinity of an element, the greater is the ability of an atom of the element to accept an electron. For the representative elements, electron affinity usually increase from left to right across periods, excluding group 2A and 5A, and decrease from top to bottom within groups. So, in one period, electron affinity of sulfur is bigger than electron affinities of phosphor, silicon, aluminum, magnesium, and sodium, but is smaller than electron affinity of chlorine. Those elements are in period 3, and in one group, the electron affinity of sulfur is bigger than electron affinities of oxygen, selenium, and tellurium, and for the polonium, it is one of the radioactive elements. From the table that we can see, it shows the electron affinities of some representative elements and the noble gases. The electron affinities of metals are generally lower than those nonmetals, and halogens have the highest electron affinities value. This graph shows a plot of electron affinity against atomic number. This is the electron affinity movement of period 3 from sodium to argon. The second periodic property is electronegativity. The electronegativity or En of an element is a measure of the relative tendency of an atom to attract electrons to itself when it is chemically combined with another atom. Elements with high electronegativity or nonmetals often gain electrons to form anions. Elements with low electronegativity or metals often lose electrons to form cations. For the representative elements, electronegativity usually increase from left to right across periods and decrease from top to bottom within groups.
So in one period, the electronegativity of sulfur is bigger than the electronegativities of phosphor, silicon, aluminium, magnesium, and sodium, but is smaller than the electronegativities of chlorine. Those elements are in period 3, and in one group, the electronegativity of sulfur is bigger than the electronegativities of selenium, tellurium, and polonium, but is smaller than the electronegativity of oxygen.
From this table, we can see the electronegativity values of the elements. The electronegativities of the elements are expressed on the Pauling scale. The electronegativity of sulfur is 2.5. Two elements with quite different electronegativities such as sodium and sulfur tend to react with each other to form ionic compounds, namely sodium sulfide. Two nonmetals such as hydrogen and sulfur with similar electronegativities tend to form covalent bonds with each other, namely hydrogen sulfide. That is, they share their electrons. The last periodic properties of sulfur, reduction potential. Redox potential, also known as reduction or oxidation potential, is a measure of the tendency of a chemical species to acquire electrons from or lose electrons to an electrode and thereby be reduced or oxidized respectively.
In one period, the reduction potential of sulfur is bigger than the reduction potentials of phosphor, silicon, aluminium, magnesium, and sodium, but is smaller than the reduction potential of chlorine. Those elements are in period 3, and in one group, the reduction potential of sulfur is bigger than the reduction potential of selenium, tellurium, and polonium, but is smaller than the reduction potential of oxygen.
From this table, it lists standard reduction potential for a number of half-self reactions. The standard reduction potential is at 25 degrees Celsius temperature and 1 bar pressure. The more positive standard reduction potential is, the greater the tendency for the substance to be reduced. Those are all the periodic properties of sulfur. So now, let's continue to the next content. Reaction between iron sulfide and dilute hydrochloric acid. If the reaction takes place, it will produce iron chloride solution and hydrogen sulfide gas. This hydrogen sulfide gas is colorless, noxious, and poisonous. This is even more toxic than hydrogen cyanide. Egg protein contains sulfur and its decomposition forms hydrogen sulfide and giving off the odor of rotten eggs.
To identify this hydrogen sulfide gas, we can use a filter paper, moisten it with lead-2-acetate solution, and it will give a black color of lead-2-sulfide on the filter paper.
The fourth content, reaction between hot concentrated sulfuric acid and copper metal. If the reaction takes place, it will produce copper to sulfate solution, sulfur dioxide gas, and water. The sulfur dioxide gas is colorless, poisonous, and corrosive gas with a very irritating odor. Even in small quantities, it causes coughing and nose, throat, and lung irritation.
To identify the sulfur dioxide gas, we can use a filter paper, moisten it with the potassium dichromate solution. This reaction is in acid condition and it will give a green color of chromium trisulfate on the filter paper. In this condition, chromium hexavalent is reduced to become chromium trivalent or Cr3+. Potassium dichromate can also be changed with potassium chromate because both potassium dichromate and potassium chromate have the same oxidation numbers, namely positive 6.
For the last but not the least content is the references I used to complete my slide. First, for the sulfur dioxide properties, I took from Giles' journal with the title is The Reactive Sulfur Species Concept 15 Years On Antioxidants Journal. The second one, for the electron affinity periodic properties, I took from Lard's book with the title is University Chemistry. The third, for the identification reaction of hydrogen sulfide and sulfur dioxide gas, I took from Svela's book with the title is Vogel's Qualitative Inorganic Chemistry. The fourth, for the electronegativity periodic properties, I took from Witten's book Chemistry 9th edition. And the last one, for the reduction potential, I took from English Wikipedia reduction potential, and for the sulfur dioxide test, I took from Indonesian Wikipedia kalium dichromate.
For the video completing my slide, let's watch and check it out.
Sulfur is the 16th element of the periodic table and is a nonmetal. In its elemental form, it is a bright yellow crystalline solid at room temperature. In this video, we are going to look at the basic physical and chemical properties of sulfur. We will also discover some real-life applications of sulfur-containing compounds, including how it is found in fuels and what happens when it is combusted and consequently reacts with oxygen. The most common allotrope of sulfur is octasulfur, where 8 sulfur atoms join together to form this ring structure and is very prevalent in nature. It is commonly found around volcanoes. Yellow elemental sulfur burns with a blue flame and melts into a deep red liquid. Its many compounds can be found in everyday life. Does cutting onions reduce you to tears? The sulfur-containing compound responsible for this is a known substance that makes your eyes produce tears. Stinky feet and bad breath? Blame those on sulfur-containing compounds too. Overcook those boiled eggs? That blue-gray lining around the yolk is due to the reaction of the iron in the yolk and hydrogen sulfide created in the whites, forming iron sulfide. Ever smelled a natural gas leak? That is actually the smell of a spiking agent, which is a class of sulfur-containing compound called thiols or mercaptans, such as methanethiol. Methane is the gas. The thiol is the sulfur-smelling part. The sulfur smell is strong enough so that you can detect a potentially dangerous leak. In fact, fuel for cars and other vehicles also contain these sulfur compounds. The combustion of these fuels also means the combustion of these sulfur-containing compounds. This results in the production of sulfur dioxide, which reacts with the oxygen in the air to create sulfur trioxide. Sulfur trioxide then reacts with water vapor in the atmosphere to produce sulfuric acid. Sulfuric acid then dissociates into its respective ions, meaning there is a higher concentration of hydrogen in our rainwater, and so the pH is lower. This means that it is acidic. Bicycle and car tires would not exist without sulfur. White latex is tapped from rubber trees. In this natural state, it is not very useful, so it is vulcanized or cooked with sulfur to make it harder, stronger, and longer lasting. In its natural state, the rubber molecules are long chains that are tangled up and only weakly linked. When it is vulcanized, the sulfur helps form extra bonds, which are known as crosslinks. This makes it harder. Did you know that curly hair has a connection to sulfur? Keratin, the main protein component of hair, also has lots of disulfide bridges. The more bridges present, the curlier your hair. In fact, straightening curly hair involves breaking these bridges, either using heat or chemicals. Do you love the smell of the seaside? That distinct smell is actually from sulfur-containing compounds released by algae and decomposing seaweed, which is very toxic. but present in low enough concentrations so that it is safe for you to enjoy your time at the beach. And finally, and maybe most importantly, sulfur is an essential element to life. It is present in one of the 22 amino acids that make up proteins. So when living things die and get buried underground to form fossil fuels, the sulfur remains there, only to be released as a OSO when the fuels are burnt, again leading us back to acid rain. So there you have it, sulfur. Not as dull as you might have imagined. Just remember volcanoes, onions, smelly feet and eggs, gas, fuel, acid rain, curly hair, the seaside, and amino acids.
So that's all my explanations about my slide, characteristics of sulfur and its compounds. I have to apologize for all my mistakes during explaining, and please forgive me. For your good attention, let me say thank you, and don't forget to click like, share, comment, and subscribe, and see you next time.